Good evening, everyone. So let us look at this question under more concept as our new topic that we started in chemistry. So under more concept, the formulas that you need to be familiar of, we can say the first formula can say number of moles is equal to mass over Mr. relative formula mass. Or you can say number of moles is equal to mass in grams over molar mass. Just the same. Another formula that we have, we can say number of moles is equal to mass over molar volume. So these are the formulas that we can use under more concept. So our first question. The first question reads, find the number of moles in 20 grams of calcium. So question 1A. The first thing we need to collect our data. Here we can say what's our mass. They are saying the mass of calcium. So we can say our mass in our question is 20 grams. It's 20 grams of what? Calcium. Then what else? The question was find the number of moles. Number of moles we don't know. What else do we have? What do we have? Volume. Do we have volume in our question? So we don't have volume. So the formula that you can use here is this one. We need to find the mass of calcium. So you can say Mr. or molar mass. You can say Mr. or molar mass. We can say if you look at calcium, the proton number is 20. The mass number is 40. So our Mr. or our molar mass, our relative formula mass, is 40. So we can say Mr. is equal to 40. That's what we need to know. So now our question. So the formula that we are going to use is this one. We can say number of moles equal to mass over Mr. Then we can say our mass is 20 grams. Our Mr. is 40 grams per mole. So this one it was 40. It was 40 grams per mole. So how do we find this value? We can say this gram is going to be cancelled with this one. This 0 is going to be cancelled with this one. Then if we say 2 divide 4, what's our answer? It's 1 over 2. So you can say 1 over 2, we say 1 divided by 2, it's 0.5. But if you want, you can use a calculator. We can say 40, no, we can say, is it 20 divided by 40? So it's 0.5. So our answer there, we can say it's 0.5 more. So this is the number of moles of calcium. B. Question B. They are saying find the mass of 3.5 moles of water. 3.5 moles of water. So the first thing, there is another thing that you need to know. You can say 1 mole is equal to Avogadro's number, which is 6.02 times 10 to the power 23. We need to know this. Then if 1 mole is equal to this, our question is saying find the mass of 3.5 moles. So again, they are saying 3.5 mole is equal to X. We don't know. Are we together there? Find the mass of 3.5 moles of water. So, in another way, we can use even this, our formula can also work this one, provided that we know the chemical formula for water. But in this case, just direct, we're not going to use this one. But this one, we can also use it if we want. But for now, let's just use, we say number of moles is equal to mass over Mr. So you can say number of moles is equal. So now water, if we say our data, they are saying we have the mass is 3.5, or the mass of 3.5 moles. The question saying that we need to find the mass of 3.5 moles. So the number of moles that we have, this is a number of moles, 3.5 moles. Then mass, we don't know. What else? The molar mass, so, or the Mr. How do we find? The chemical formula for water, it's H2O. Now I'm going to say, what's the mass for hydrogen? We can say the mass for hydrogen is 1 times, this 2 means that you have 2 hydrogen times 2. We are getting a 2. This one was for hydrogen. What of oxygen? We can say the mass number for oxygen is 16. And you only have 1 oxygen there. We can say times 1, which is giving us what is 16. When we add, what do we get? We can say 2 plus 16. We are getting 18 molar or more grams per mole. So that's our Mr. or our relative formula mass. So now coming to our formula, you can say number of moles is equal to mass over molar mass. So since number of moles we have, they are saying it's 3.5. You can say 3.5 is equal to mass we don't know. The molar mass it's 18. So you can say the cross multiplication there, we say mass is equal to, then we say now our calculator, I can say 3.5 times 18. So have 63. You have a 63 there. We can say 63. Let's say 63 grams. That's the S signs for mass. So this is how we find the mass. Then question 2. Which one? Which question? Question 2. Can you move on to question 2? So the question 2 reads, a gas cylinder has a capacity of 200 centimeter cubed. Calculate question 2A, Roman numeral 1, the mass of carbon dioxide that can fully occupy it at RTP. RTP is room temperature and pressure. Room temperature and pressure. So we can say find the mass of, what is the question? A gas cylinder has a capacity of 200 centimeter cubed. This is volume. Calculate the moles of carbon dioxide. So, question 2. Question 2. we can say our data the question was saying a gas cylinder has a capacity of 200 centimeter cubed. Calculate the moles of carbon dioxide that can fully occupy it at room temperature. So we have carbon dioxide. We can say number of, since they are asking for us to find the moles, we can say number of moles we don't know. What's our mass? We are not given. What of? So the formula that you can use according to our data, what you have, we have volume. Volume is 200 centimeter cubed. Remember always under mole concept, you need to convert this volume into decimeter cubed. So how can we convert? We're going to say, going to divide it with 1000. So our answer will be 0.2. 0.2 decimeter cubed. That's our volume. Then what else? Since the question was saying that we find, it was saying calculate the moles of, need to find the moles now. So our formulas, or our formula that we use to calculate this, we can say there is this formula, number of moles is equal to mass over molar volume. This is our formula that you can use there. Or should we say, there is another formula that you can say volume is equal to number of moles over molar volume. So among this formula, so since we don't have mass in our question, if you check well the question, if you are to check well our question saying, question 2, a gas cylinder has a capacity of 200 centimeter cubed of volume. Calculate the moles of carbon dioxide that can fully occupy it at room temperature. Since we don't have a mass there, we can use this formula. So we get back to our question. We can say volume is equal to number of moles over molar volume. So we can say what was our volume. So, and another thing to our data, we need to know that the volume, the molar volume under room temperature, it's 24 decimeter cubed. It's a constant number, you need just to know this one. Then under STP, so this is under, we can say this is under room temperature and pressure, TP. So we can say, coming to our formula, we can say what's our volume that we have. Our volume that we calculated, that is 0.2. It's 0.2 decimeter cubed is equal to number of moles we don't know. Then what is our molar volume at room temperature? It's 24 decimeter cubed. So you can cross multiplication there. This means that if you have 1 there mathematically, you can say cross multiplication. We say number of moles is equal to 0.2 decimeter cubed times 24 decimeter cubed. So our solution there, if you use our calculator, we can say 0.2 times 24. It's 4.8. So our answer can say 4.8 moles. So this is how we get the number of moles by using the formula.